Hello everyone and welcome to your study guide lesson. It's lesson 5-8, Scale Drawings and Models. This lesson is found on page 113. So after scanning the lesson, I've noticed that for this lesson we're going to learn about using scale drawings and models, which means it's a small model, right? Or it could also be larger for something that would represent it smaller, but it's to scale, meaning that a ratio, if we were to write a scale, it would be, for example, for every 1 inch, it's 10 feet, everything would be the same way. Every measurement that you see in inches would be the equivalent in feet, okay? So that's what they mean by scale. And we're also going to construct scale models. Now, we're not really building anything at this particular lesson, but what we're going to do is actually draw scale models. For a quick review and a key answer, let's solve for x. Now remember, we can do the cross product style where we do 3 times 5 equals 15 on one side, and on the other side we have 10x. Then we isolate the x right there, we isolate it, so we bring the 10 over to the other side, and now we have 15 divided by 10 equals x, which will be 1.5 equals x. Okay, that's one way to do it. The other way would be just by looking at the 10 and what did we do to the 10 to make it 5. We know we halved it. We made it a half. This would be called a scale. This is what we mean when we talk about scaling something. Like whatever you do to one, the rule must maintain for every other measurement. So let's say here that we were using an actual scale, and let's say that for every 10 inches that you see, it's going to be 5 feet. Okay, so it looks like we went down, we just cut the number in half, so we must do the same thing here. So if I have 3 inches, then it's going to be 1.5 feet, right? Because this 5 is half of 10, this needs to be half of 3. So x equals 1.5. Many of you can do it mentally like that. Make sure to write down your answer as a key answer. So continuing with the definition of a scale. Okay, the scale is the ratio of a given length on a scale drawing or model to the corresponding length on the actual object. Okay, so we have the model to the object. What is their relationship? That would be the scale. When the scale drawing or the model has the same unit of measure, the scale can be written without units. We don't need to say that it's all inches because we know it's all inches. It's all written in one type of unit, and it doesn't matter if it's inches, it could also be feet. As long as it's all the same unit, we're going to say that it's 1 to 10 or 1 to 15 or so on. This is called the scale factor. A scale of 1 inch to 2 feet can be written as 1 inch to 24 inches. You see, because every foot has 12 inches, so 2 of them would have 24. So we just made it a scale factor. So its scale factor is 1 to 24. It doesn't just have to be inches. This 1 to 24 can be for every 1 meter, there's going to be 24 meters. For every 1 mile, there's going to be 24 miles. Okay? That's why we don't need to include the units. We just know that that's how they compare. Okay. Now we're going to use cross product, or what we've done in the past for equivalent fractions or so on, to identify these missing variables. Okay, so we have 1 inch is 3 feet. So 1 inch for every 3 feet. So 1 inch, we have to change it now to the scale factor, to inches. Every foot has 12 inches, so 3 of them will have 36. So my scale factor is 1 to 36. Okay? Sorry, that's an ugly 36. And for the next one, we have 10 centimeters. Right there, 10 centimeters is 5 meters. So 10 to 5. We can change. Remember that how many centimeters are in 5 meters? For every meter, we have 100, right? So if we have 5 times 100, it's going to be 500. Because that's how they compare to one another. Okay, every meter has 100 centimeters. So we change it to centimeters. And there it is. So my scale factor is 10 is 500, or 1 is 50, right? Take away 1 0 there and take another 0 away from there to bring it down to 50. So you're probably wondering what this is. I was wondering too when I first saw it. It's actually the world's largest bat, but I don't know where this bat is. So for a key answer, please Google on your phone quickly or on your laptop or tablet, where is the world's largest bat? What city? I wouldn't be surprised if it's in a baseball city like Boston or Chicago, even New York. Okay, let's see. Real world link. Baseball. The world's largest baseball bat is 120 feet long and 9 feet in diameter. Remember, diameter is the distance across the circle. Professional baseball players typically use bats that are 34 inches long. So we have 120 feet and 34 inches, okay? Let's see here. Fill in the blanks to complete a proportion that could be used to find the diameter of an actual bat. So we know that the diameter here is 9 feet. 9 feet, we could change that to inches and it would become 108 inches. You see that? Because 9 times 12 is 108. So length of the largest bat. We do know that, well, let's look here what we have to fill out. We have to length of the largest bat in inches. And we know that the length is 120, so we have to take 120 feet times 12 so that we can convert it to inches, okay? And that's going to give us 1,440 inches. And we already know that how long it is. The actual length of the bat, which is what we're being asked to write here, length of actual bat, is 34 inches. 34. And what we're looking for is x. Again, we can do cross product. Okay, we can do cross product, or we can see what we did to the 1,440 to get 34. I guess you could divide this by this, and whatever you get, you divide this number by it too, and you get your x. But let's do cross product so that it looks like this: 1,440 x equals 3,672. So that's 108 times 34. That's what we did. We did cross product. I multiply those two, and I multiply those two. Now I'm going to isolate my x, so I'll bring over my 1,440. I'm just going to get rid of that there, put my arrow that I'm bringing it over here. Remember that it's multiplication on this side, so on this side it must be the opposite, which will be division, and I'm going to divide it. And it equals 2.55 inches, so about 2.5 inches. Okay? Feel free to use a calculator whenever you're doing these large numbers. That's what I did, because otherwise it would take a long time to do this. What's important is that you know the process. Okay, let's continue to practice using scales. The actual measurements of 4-room apartment are shown in the table below. Use a scale of 1/2 inch to 4 feet to find the length of each room on the drawing. So here we have the living room, the kitchen, the bathroom, the bedroom. The actual length in feet are 14 feet, 10 feet, 6 feet. So for every 4 feet, we're going to have 1/2 inch, right? For every 4 feet on the top, we're going to have 1/2 inch. We can keep it as feet. We don't have to change it to the scale factor. We can keep it as feet so that I know for every 4 I have here, I'm going to have 1/2. So I have 4, okay? In 14, it's going to look like this: 4 plus 4 plus 4 is 12 plus 2. That's what 14 looks like, right? So here I have 1/2 inch, and another 1/2 gives me a 1 inch, 1.5 inch, and then 1/2 of an inch. 1/2 of a 1/2, right? 1/2 inch. So here I have 1.5, and then 1/2 of a 1/2 is a quarter, right? 1/4 of an inch. So I have 1.5, right? 1.5 and a quarter is 1 3/4. 1 3/4. See how I did that? You could also do it like this, as cross product, where you have your 4x equals 14 times 1/2 is going to be 7. So 4x equals 7, right? You could also do it like that. And for the next one, I set it up so that we can do it like that, where we have our actual scale for feet is going to be 1/2 inches. So 10 feet would be what? So we multiply these two across, and we get 4x equals 5. 4x equals 10 times 1/2 is 5. Okay, so 4x equals 5. And then x equals 5 over 4, because we bring the 4 over. And you know how many 4s are in 5? 1. And what do you have left over? 1/4. Okay, so you saw how I did that. Please do it for 6 and 12. Okay, set it up so that you have your 4 over 1/2 inch equals 6 over x, and you do the same with the 12. Go ahead and do that, please. I'll be looking for that when I check your homework. Okay, now we're actually going to construct or draw a model drawing, okay? A model drawing. Describe the process for constructing a scale drawing. Then use the information above to construct a scale drawing of one of the rooms. Here we have the kitchen. And for the kitchen, we know that every 1.25 inches will be 10 feet. Correct? Remember that 1.25 will be 10 feet. So, and remember that this grid paper, each little square is 1/4 inch. So here we have 1/4, 2, 1/2, 3/4, and a whole inch. There's our whole inch, and that would be that entire inch right there. Those 4 from there to there, plus another 1/4 would be 10 feet. That would equal 10 feet. Okay, so knowing that 1.25 is 10 feet, I have to draw length. This is the length of the actual room. So I have 1/4, 1/2, 3/4, and 1. So from here to here is 1 inch, and now I need another 1/4. So this will be 10 feet. Now they don't tell us the width, so we can make up the width. And I'm just going to go ahead and just make the width at 1 inch. Okay, at 1 inch, like that, and then bring it right down. And there's my length. And my length here is 10 feet. You see that? Okay, so copy down the steps so that you know how to do this. First, we have to find the drawing lengths, and here's our drawing length. Okay, we have 10 feet is going to be 1.25 inches. Then decide how much each unit on the grid will represent. And we were saying that each little square is going to represent 1/4 inch. Okay, 1/4, 1/2, 3/4, a whole inch, and then 1.5, 1.25. Sorry. So that's what we did. Calculate the number of grids needed, as we just did now. And finally, draw the line segment. There, we drew it to make the scale drawing. So you understand this is exactly 10 feet, this is exactly 10 feet. And over here we have just 1 inch, which if you're able to do the math is exactly 8 feet, right? Because every 1/4 is going to be 2 feet. All right, and now you can go ahead and write your 2 or 3 sentences summarizing the lesson where we use scale drawings to form models. Okay, we converted from inches to feet. We talked about the scale factor and identified what the x value is in equivalent fractions, or what we can say we did cross product already as well. Okay, see you in class, everyone.